Hi, this is Mrs. Downey with Algebra 2, and today we are covering Chapter 6, Section 4, Rational Exponents. The objective today is to simplify expressions with rational exponents. So in Algebra 1 we worked with exponents, and now we're going to work a lot more with exponents that are fractions. We're going to learn how to convert those to rational numbers, and the first thing I want you to do is read the bell work here. Simplify the formula below with a equal 25 and n equal 2. So our formula is a to the power of 1 over n equals the nth root of a. So simplify that by plugging in the numbers. Do that in your math journals. Okay, when you do this, I said that a is 25, so we should have 25 to the 1 over, and n is 2, so 25 to the 1/2 is what you should have written first. And then when we convert that, and this is actually a rule we're going to start to use from here on. If we have 25 or any number to a fractional power, we can convert that like this. We can say that is the square root, because n is 2, of 25. And actually, because it's a square root, we just do 25, which comes out to 5. Okay, now let's do that again with a equals 8 and n equals 3. When you do that, now we're going to get the cubic root, we're going to get 8 to the 1/3 equal the cubic root of 8, which is equal to 2. So in your own words, in your math journal now, I want you to conclude something about this. Just write it in your own words. What are your conclusions about what we just did? So pause the video and come back when you're ready. Okay, so now that we're done with our first page, let's move on with our conclusions. Now let's do the same again with some new numbers. And then we're going to take it one step further. So it says, let's do the same here. Let a equal 7. So we're going to have 7 to the m over n. So m is 4, n is 3. So if we have a fraction like 4/3 as a power, we can simplify that to this. The denominator, the bottom one, becomes our index. A is still our main number. And the top one is the power. Think of this, strong on top, power. So that's the power. That's the root, or the index, right? And so this is what we get. And we can now also say that this is true. The cubic root of 7 to the 4th power. These are the same. All three of these are the same. So now we're going to put these to use with our work. So we have some essential understanding here. You can pause and read this. And it's just stating what we said a moment ago. If we have the square root of 36, we can do this backwards. You know, that was a square, right? And this would be your a down there. So we can say that this is 36 to the 1/2 power. And then look at the next one. We have the cubic root, so that's 1/3 to be a cubic root, and 64. And then the last one, whoops, went right through that. There we go. So the last one, we can say that the fourth root of 16 is 16 to the 1/4 power. Okay. So now, looking at problem 1, we're going to do more of the same. Simplify each expression. And they give us, what is the simplified form of each expression? So they give us 216 to the 1/3 power. So we know that's going to be the cubic root of 216. And now look at the right side. We have 7 to the 1/2 times 7 to the 1/2. And that's going to be radical 7 times radical 7. So rewrite them as radicals first. And then we know that 216, if you have a quick calculator, is 6 cubed. So we have the cubic root of 6 cubed, and we know that that's going to cancel out to be 6. And over here we had radical 7 times radical 7. We know that's going to be 7. So there's 2 quick problems for you for problem 1. And I would like to pause right here and have you open your workbooks and work the first 3 problems, 1, 2, and 3, on 6-4 practice K. So pause now. There's one other problem I didn't show before I set you loose on your homework, and that is the 3rd problem here. When we're multiplying powers with fractional denominators, we can combine that. So we can say 5 to the 1/4 power is the 4th root of 5, and 125 to the 1/4 power is the 4th root of 125. Now, what we can do is multiply those together. The 4th root of 5 times 125, which is the 4th root of 625. And if you plug that into a calculator, you quickly find that that root of 4th root is 5. Now you can work number 3. So pause here. If you need more work or more practice, here's the got it's. All right. So we know that this is the square root of 64, which is 8. And what do we have here? That's the square root of 11 times square root of 11, which is just square root of 121, which is 11 times 11, which is 11. Okay? And then that's the square root of 3 times square root of 12, which becomes the square root of 3 times 12, which is 36, which is 6. Okay, problem 2, we're going to come in and say, converting between exponential and radical forms. So what are x to the 3/7 and y to the negative 3/5 in radical form? So x to the 3/7 becomes, like we did at the beginning, the 7th root of x cubed, or we can say the 7th root of x cubed. And the second one, y to the negative 3/5 equals y to the negative 7/2. And that we're going to write as 1 over y to the 7/2, because remember the rule for negative exponents, which becomes 1 over y, the square root of y to the 7th, which we can break up to 1 over the square root of y to the 6 times y, and that means we can take out our y cubed here times radical y, or we can say, excuse me, delete that. So these are the 2 answers that are acceptable. Okay, either way, and we're going to pause here. Okay, I've not got enough time just to do this last one. We've got, what is the square root of a to the 5th? And we're going to say that that is a to the 5th times 1/2, or a to the 5/2. And this one, the 5th root of b cubed, becomes b to the 1/5 times 3, or b to the 3/5. Okay, and we left off right here where we said that the square root of a to the 5th becomes a to the 5/2. And then if I have the 5th root of b cubed, that's the same thing. Remember, this is the root on the bottom, and that's the power on top. So it becomes b to the 3/5. Okay, next. That's it for problem 3. So let's pause right. Okay, so we're back after about a 6-minute break here to work numbers 4 through 9 and 12 in our workbook. If you need extra practice, I have the Goddets that I don't have the Goddets. All right, so let's move on to problem 4. Problem 3 we're going to skip for time's sake today. We're combining two smaller lessons into one. So this is doable, skipping problem 3. Problem 4 says, what is the 4th root of x to the 3rd power over the 8th root of x squared in simplest forms? So what we have to do is we have to think our radicands are different, but both of the powers are the same variable. So let's write the expression using exponents. So this becomes the 4th root of x cubed becomes x to the 3/4 power, and the 8th root of x squared becomes x to the 2/8 power. 2 over 8. And again, remember, this is the index, it's on the bottom, and the power is on top. So now we've got a fraction divided by a fraction, right? So what can we do? Subtract them. So it's going to be x to the 3/4 minus x to the 2/8. And we can simplify 2/8 to 1/4, and now we have common denominators. So now it's just x to the 3 minus 1 over 4, which becomes x to the 1/2, which is just the square root of x. And that's all there is to that on problem 4. And there's some extra practice if you need it. And I would like for everybody now in their workbooks to work number 14 and 15. And I will give you about 4 minutes for that. And I'll pause the video. Okay? Now I'm coming back from working problems 14 and 15 after problem 4. And we're moving right along here on problem 5. Problem 5 says that we can simplify a number with a rational exponent by using properties of exponents or by converting the expression to a radical expression. So let's look at what they have in store this time. So what is each number in simplest forms? So they first give us 16 to the negative 2/5, and they give us two different methods. So let's just focus on method 1 here. And so it says, what's the first step? Rewrite your decimal exponent as a fraction in the lowest terms. So what would negative 2.5 be? Negative 5/2, right? So there's 16 to the negative 5/2 right here. And then we know that 16 is 2 to the 4th power to the negative 5/2. And now we've got a power times a power, so we can just multiply, right? So that becomes to the negative 20/2, which is negative 10, which becomes 1 over 2 to the 10th power. And 2 to the 10th power is 1,024. So our final answer here is 1,021 over 1,024. Now let's look at method 2. Method 2, we've got the same thing. We're starting out with 16 to the negative 5/2. And now they're going to take that as a negative exponent. So 1 over 16 to the positive 5/2. And then they rewrite that as 1 over radical 16 to the 5th power. So just using the rules we learned today. And that becomes the square root of 16 is 4, so we've got 1 over 4 to the 5th power, which is 1 over 1,024. So it is whichever method makes sense to you. I prefer method 1 myself, but it is up to you. In the end, we just want to get to the right answer. Now we've got another problem here. We've got negative 32 to the 4/5. Now they're throwing in a negative power. So negative 32 to the 4/5. Now we know we're working with fifths, so how about negative 32 is negative 2 to the 5th power. All right, and so I'm going to leave method 2 off this time. And so we've got the power to a power, so multiply. 5 times 4 is 20. 20 over 5 is 4. So we have negative 2 to the 4th power, which is 16. And I will quickly show the other in case if you prefer that. You can pause it at home and look over it. Okay, here's some extra practice if you need that. And at this point, we're going to pause and do workbook practice K, number 17. It shouldn't take you but about 2 minutes, so let's pause for 2 minutes. Hi, this is Mrs. Downey, and we're just coming back from problem 5, workbook pages. We did practice K. This is on 6-4, Rational Exponents. We did problem 17 for about 2 minutes. Now we're moving right along to our last problem of the day. This is problem 6, writing expressions in simplest forms. Now, notice our note at the top. It says to write an expression with rational exponents in simplest form, write every exponent as a positive number. So no negative exponents. Remember that rule, which we've hit in Algebra 1, and now in Algebra 2 we've hit on it again. Okay, so it says, what is each expression in simplest form? We have two problems here which I'm going to work with. The first one, and notice that we've got a plan here. And it says, what is the first step in simplifying a radical expression using the properties of exponents? Rewrite the radicals using rational exponents. Okay. So the first thing we're going to do is look at what's given to us. Negative 8x times radical xy all to the 2/3 power. Okay, so our first step is just to rewrite that. And now let's start working on it. What they've done here is they've taken the 2/3 and they're going to distribute it basically to every term. The negative 8, the x, and the radical xy. So let's take a peek at that. And there it is, distributed to all three terms. So there's the negative 8 to the 2/3, the x to the 2/3, and the radical xy. But notice what they did to the radical xy. They turned the radical xy to xy to the 1/2 power, then to the 2/3. So that was just a little conversion there. Okay. So our next step is to keep cleaning it up. And notice that they've now turned, let me extend my page here. Sorry. All right, so they've extended negative 8 to negative 2 to the 3rd power. And they're trying to get everything to a power to a power. We're trying to just keep crunching down till we get these as compact as possible. So we've got negative 2 cubed all to the 2/3 power, and then that's the same. And then they multiplied our two powers. Remember, a power to a power, multiply. So 1/2 times 2/3 becomes 2 over 6, which is just 1/3. So this all right here is this now simplified. Okay, so these go together. This is that, and this is that. Okay, our next step now is to simplify again. So clear. All right, so from this step, they've got a power to a power again. So 3 times 2/3 becomes 6/3, which simplifies to 2. So we have negative 2 to the 2 power. So these are the same. Simplified. This is just a straight copy down. And now they're distributing this 1/3 across to the x and the y. There and there. Okay, and then our next step is to combine all those x's. So this is our last step. What had they done here? Let me get my pen. All right, so negative 2 squared is your 4. And then you have x to the 2/3. And remember, when their powers are the same base, you just add the powers, keep the base. So 2/3 plus 1/3 plus y to the 1/3. Oops, that's a times y to the 1/3. So this x to the 2/3 plus 1/3, that becomes x to the 3/3, which is just x. So there's that. So we have 4x, and then our y to the 1/3. Now we're going to convert the y to the 1/3 to the cubed root of y. So our final answer becomes 4x times the cubed root of y. Nice little number cruncher. I think it was harder to talk through that than it is to do. These actually go pretty fast when you work them. And here's our second problem. Okay, so we've got 16y to the negative 8, all to the negative 3/4. So there's a power to a power again, but notice that the negative 8, here's the tricky part, it only goes with the y, it didn't go with the 16. So you can't just do a power to a power there. You've got to distribute that negative 3/4 to both 16 and the y to the 8th, negative 8th. So notice they've done that. There's the 16, there's y to the negative 8 to the negative 3/4. Now fix those. What is 16? Well, we know 16 is 2 to the 4th power, all to the negative 3/4 power. It's the same. And notice that they did the math on our exponents there. Negative 8 times negative 3/4 becomes positive 24/4, which is y to the 6th power. Okay, so these are 1, those are 1. Okay, our next step is keep cleaning it up. So 2 to the 4th to the negative 3/4, there's a power to a power again. So what do? Multiply. So it becomes negative 12/4, which is just negative 3. So that becomes 2 to the negative 3. Y to the 6 stays the same. And clean it up one last time. 2 to the negative 3rd becomes 1/2 cubed, which is 8. There that is. So here, let me clear. Come on, 8. This is that. And then y to the 6 on top. And that's, I believe, everything. Yes, there's our got it's if you need extra practice. And now I want everybody to do the last problem for us in the workbook. This should take no longer than 5 minutes, number 20. And when you finish that, turn them in. I'll take them up at the end of the hour, which we should be pretty close now. So that concludes our lesson. Thank you for watching, and work hard and have a great mathy day, you nerds. Lovely nerds. Oh, and here's a quick picture of the overview of everything that we just did. Okay, thank you. Oh, and this is 6-4. What should I say? There you go. Thank you.